Hi, in this video series, we're going to be explaining data structures and algorithms, as well as implementing them in C++, starting with the stack. So, here's a demo of how to use the stack that we're going to implement. First, we're going to instantiate an empty stack S. We're going to push in 2, then we're going to push in 4, then we're going to push in 6, and then we're going to pop and print out the result of popping. So what popping does is it takes the top element off of the stack and returns it to you. So 6 will be printed out. What peeking does is it takes the top element and returns it to you, but it doesn't remove it. So this will print out 4 without removing it. And then we push 9 on top, and then we print out the whole list. So if we run this, you can see we pushed what we just talked about. Okay, now for the fun part, let's implement it. So here we have our declaration file for the stack, and we're using generics or type names so that we can make stacks of anything. We can make stacks of integers, strings, your own class, whatever. Under the hood, what it is an array of your type, and this is allocated on the heap. We have a variable called size and a variable called capacity. So the actions that you can do are create a stack, specify the capacity of the stack when you're creating it. Of course, you have to be able to destroy it, push to it, pop the element, peek the element. You can get the size of the stack, you can see if it's empty, and you can also print out the stack. Now, we include the implementation over here. So, when we're creating a new stack, we instantiate the allems, which is an array of size capacity. By default, capacity is 100. When we destroy the array, it's important to have some cleanup when you're working with the heap. Okay, when you're pushing an element, what ends up happening is we have our dynamic array allems of size 100, and we start off with this variable called size, which is going to be pointing to, it's going to be 0. Size is an integer, it's an index, and it's going to be pointing to the first element. So when we're pushing, we are taking the element that we're pushing in, so say it's 2 in our example, and then we are taking this size variable and we're incrementing it. That's how you push. If we were going to then push 4, we would index allems at size and put the element there, and then we would increment size. And so that's how you're able to push. Now when you're popping, you're taking the element that's 1 below the size, which would be 4 in this case, you're returning it, and you're also decrementing size. Okay, so when we do that, now if we were to push again, if we were to push 6, 6 would go here and overwrite this 4. Oops. And that's how it should work. Now, one thing you might notice here is that we are growing the array when we hit the capacity. So imagine we appended 100 elements, okay? So we're getting all the way here, this is all full, and then we want to push. Okay, so we push the element, but now there's a problem because size is now, it's gone off. So next time around when we push, it's going to be a problem because you can't push here, that's not allocated to us. So grow, what grow does is it increases the size of array. It's going to duplicate the amount of units we have. So if the capacity was 100 before, now the capacity is 200. And the way it does this is it's going to instantiate a new allems, which we're going to replace allems with. Remember, allems was that array we were talking about. And it creates a new capacity, which is double the previous capacity. And it fills in the new allems with the old elements. then it clears the old allems array so we can free up that memory, and then assigns the allems pointer to this new allems array that we have on the heap, as well as updating the capacity. So that's what grow does. It's important so you can add as many elements as you want, as we demonstrate in this script, where we are adding 110 elements and then printing it out. As you can see, it is plenty capable of doing that. We could even make this 1,000, and you could see this array will duplicate its size as many times as necessary to make sure that everything's working. Okay. Peek is the same as pop, except we are not decrementing the size. We're not removing any elements. And size returns size is empty, returns if the size is 0. And then the last thing we have is printing out the array. So in this line, when we do standard cout s, that works because over here we are defining the operator that allows this printing to happen. So we're just looping over all the LMs and printing them out. All right, that's it. We've talked about the stack. And in the next video, we're going to be talking about a very similar data structure called a queue. So I'll see you there.